Hi, welcome back to SQL Server 2016 Administration. I'm Steve Jones, and this is Section 5. We'll look at improving query performance. In this section, we're going to take a look at our traditional or normal row store indexes, the actual structure inside SQL Server and how these are used. We'll talk about how to create and modify these indexes in order to improve the performance of the SQL Server databases. We'll also talk about the difference between clustered and non-clustered indexes. We'll look at column store indexes, which also can be clustered and non-clustered, but are slightly different, so they deserve their own section. And lastly, we'll cover how index views are created and used. Welcome to SQL Server 2016 Administration, and this is the video on row store indexes. In this video, we'll take a look at what a row store index is, how this helps performance and data integrity, and how it relates to primary keys and foreign keys. Row store indexes are normally just what we call indexes in SQL Server. However, they're row store indexes because that's the structure of the index. It mimics the row storage in the table. An index typically contains a portion of the data with links back to the actual data, though it could be the data itself, and we'll see that in a later section. And this is similar to how an index in a book actually works. So let's look at an example. Let's imagine I have a book and I have this sentence on page 1, so it's a very short, simple book. And I have numerous other pages as well that go through, and I'll end on page 58 with this sentence. Now, when you typically have an index in the back of a book, it will have entries of various words with pointers. And what this really means is that this word brown was found on page 1. Notice that that word doesn't exist on page 58. Apparently it doesn't exist on any intermediate pages. However, dog exists on both page 1 and page 58. The index is allowing us a different way to find the information in the book by condensing down particular items and then pointers to where they are in the book, in this case the page number. It's a different way for us of finding the information in the book. Certainly if we wanted to read the book through the index, it would be very cumbersome because we would have to go and find all the number 1s and all the number 2s and all the number 3s. And even then we wouldn't know what order those appear on page 1 or page 2. But if I want to find where a particular item has occurred, the index is a very efficient way of doing that. The SQL Server uses this as well. Without indexes, it would have to look at every data page in a table to find the information it would need for reads or to find the information it needs to update in writes. With the useful index, however, SQL Server can just look for specific data pages and work with those. Now, we want to avoid reading the full table because this is memory intensive. It requires reading all the data from the table, which fills up the buffer pool, pushes other data out. Now, an index itself typically only stores the information it needs in the index, plus the clustered index key or the heap RID in order to find the original information if it needs to do that. That means that each read of the index is a smaller amount of data being read. However, these indexes must be updated. So every insert, update, or delete to the table also requires that the index be updated. Lastly, these indexes are how we enforce primary keys and foreign keys. The indexes can be unique, and so they can be used to ensure that we don't insert duplicate values, which would enforce a primary key. The indexes can also be used to ensure that we can look up the data into a foreign key table and ensure that it exists before we insert data into a child table, which enforces the primary key. Because these indexes have to be updated, we want to limit the number on active tables to about 4 to 6 indexes. This really depends on how heavy your write activity is, and it will vary according to your system. If you have read-only tables or tables that are rarely updated, you may have many more indexes. In fact, in read-only data warehouse type systems, typically you'll have 10 to 20 or more indexes on the table. Now, the first column that's included in each index should be one that is used in where clauses, and we'll look at that in the example slightly. We can use multiple columns in an index to make them more useful. We certainly do want to index our foreign keys because it makes our inserts, updates, and deletes of foreign keys much quicker, as well as the queries. And then we want to avoid indexing very wide string columns. We're trying to make indexes work very quickly, so if we have wide character columns that say have thousands of characters, the index doesn't necessarily provide us benefits if we have to read through all that data. We can also create what's called a covering index. If there are queries that we run quite often, then we can include all the columns that are going to be returned by that query or used in the where clause inside of the index, either as index keys or as include columns. Something for you to consider when you're administering a system and trying to increase performance. Let's look at a demo of how this works. Here I am back connected to my demo instance, and I want to create a table here, and I want to insert some random data into it. So I'm going to run this query. Very quickly, I inserted about 1,000 rows into this table. And if we wanted to look at this, we would see some different data. I'm going to turn on my actual execution plan, which is actually this value right here. We'll click this on so we know it's on. And I'm going to return some data. So in this case, I'm going to look for the index being A. Now when I do this, I get a number of values back. You'll see I get an ID and date for different values. And my execution plan here tells me that running this query means that I scan the table. So I had to scan all of the data on the table. Let me see if I can get this to come back up again. You'll notice that the storage is row store, which is in line 5. And I had to read 1,000 rows. I read every row of the table. If this was 1,000,000 rows, that could potentially be a problematic query, run slowly for lots of people. So I want to create an index. In this case, I use the create index command. I give the index a name. This has to be unique for the table. I tell where I'm going to create this index, which is going to be on this table. And then I give the columns. In this case, I'm only going to include one column as the index key. So this will be the index value as in the book. However, inside of the index as well, we will include this other data, which means this query will be covered because my ID is included as a part of this, my date is included, and my index character is part of the key. So when I run this query, I won't need to actually go back to the main table and retrieve any data, which should result in a more efficient query. So I've created the index, and let's rerun our query. Now when we go to look at our query, what we find is that we used an index seek, and you'll notice that the number of rows read is only 37, not 1,000. The index has dramatically reduced the amount of data that I have to read.